Hello and welcome to Thursday's edition of Cracking the Cryptic, where after the absolutely wonderful puzzle from James Sinclair, the Fog of War puzzle that I did yesterday on my return from Portugal, I've got another treat for myself today in the form of Copycat Confusion by Phistomefel, the new Phistomefel puzzle. I've had a quick look at the rules before I turned on the webcam, and I've definitely seen a rule set a bit like this before, possibly even from Phistomefel. The idea is that the lines have the exact same composition of digits, or some lines have the exact same composition of digits as each other. They also have some other features that we will get onto, but this has got 4 stars out of 5 for difficulty. And if you're familiar with the channel at all, you probably know the regard with which, well, the high regard in which I hold Phistomefel. He has been, well, I don't know how many hours of pleasure he has given me over the years, but it's a lot, and he has also baffled me in equal measure. So anyway, I'll read the rules of this one in a moment or two's time. I have a wealth of birthdays to catch up on following my trip, so I will do those in a minute as well. And just a quick update. Thank you. Well, firstly, thank you so much. I mentioned yesterday that I had just a horrible experience on arriving in Portugal, trying to hire a car from a company called Surprise. Never ever use that company. If you ever have the option to use a different hire company, in the end I ended up hiring a car from Hertz, and they were absolutely fine. But Surprise, you should not touch with a barge pole. And that's my public service announcement for the day, and quite what EasyJet are doing recommending them to their customers, I have no idea. Shame on you, EasyJet. Very, very naughty. Anyway, some of you asked for a longer story. I will save that for a different time. I'm in no mood to discuss it when I'm in a good mood from doing puzzles. But thank you to those of you. So I got some emails, and there were a lot of kind comments yesterday. But apart from that, the holiday was good. Anyway, I've got to do birthdays. The only other thing to mention is we are closing in, believe it or not. The year rushes past. We are closing in on the 1st of September. On the 1st of September, if you're a patron of the channel over on Patreon, we have quite a cool treat for you in the form of a sudoku hunt themed on sandwiches in films. And if you think there's no such, if you think that's just what, there are no such thing as sandwiches in films, oh, let me tell you, there are. So a lot of sandwich sudoku with some references to movies you'll no doubt be familiar with, one or two that you might not be, but we're quite proud of this one, and we do hope you enjoy it. The competition will go live at 4 p.m. UK time over on Patreon. As I say, it's a couple of bucks to join us there, and it's our Sudoku Club, so well worth having a look at. Well, I say Sudoku Club, there's a lot of extra crossword content as well. Now, what else? Let's do these birthdays. Let me catch up, and I apologise if I'm a bit late to some of these. Holidays got in the way. I don't have a holiday very often, and I do try and make sure, and I have managed to make sure so far at least, that if I do have a holiday, the videos continue. So forgive me if these wishes are a little bit tardy. Anyway, let's start with Brian. As Maverick flies past, Brian, I think it might be your birthday today, actually. My notes aren't warning me that isn't the case. So, Brian, your daughter Hayley, who I know is 16, I don't know your age, Brian, wrote to us. And I love this. Originally, the two of you watched the channel to help you fall asleep. But now you find the channel keeps you awake. Well, as it should. And Brian, I gather you might be having pound cake, but you're planning to put chocolate ice cream cake on the top of the pound cake. Well, that sounds innovative and possibly calorific, but no doubt tasty. So I hope you have a great birthday. Next, Gisela. I know you've turned 42 today. Answer to the life, universe, and everything. I know this because your son, I think it's Kale. I hope I'm saying that correctly. It could be Kale. Kale, yeah, I think Kale. And Gisela, I know you don't like chocolate cake, so I don't know what you're going to do, but I do hope you have a great birthday anyway. Joseph, it's your birthday today, and I know this because your wife Tang wrote to us, and I hope you do have chocolate cake, Joseph. Next, I am late with this one. This is a 10-year wedding anniversary for Kayla from your husband Amir. I think it was back on August the 20th, so I'm terribly late with this. But I know the two of you were planning to go with your family and your dog to Niagara, which sounds amazing. So I hope you had a great time. LC, it's your 23rd birthday today. And I know this because your girlfriend B wrote to us and also told us that she loves you very much. Lewis, you turned 22 recently. I think this was possibly back on the 20th as well. I know this because your friend Adam, who you met at university and then shared a flat with, wrote in. I think, Adam, it was your birthday the day after Lewis's birthday. And apparently you each didn't know the other watched the channel. And then, Lewis, you heard the theme music being played in the flat's kitchen and went in to say, hang on, I watched that channel as well. So I wonder how true that is of a lot of people. Whether their friends might be watching, cracking the cryptic for a dose of logic every day. Anyway, Lewis, I hope you had a great birthday, obviously. And then finally, down there in New Zealand, I'm late with this one, 22nd of August, Melissa, you turned 36, and I know this because your husband Jay wrote in and said you'd like a shout out. So Melissa, I hope it was a great birthday, and I'm sorry I'm late. And that is all the news. So as Maverick sounds like he's circling outside my window, apologies for the aeroplane noise. Let's have a look at Copycat Confusion. And I almost said copyright confusion there. That's what I get when I play my guitar intros for too long and we get copyright messages from YouTube. No, this is not that. This is Copycat Confusion. By Phistomefel, the rules are as follows. Normal sudoku rules apply, so we have to put the digits 1 to 9, once each in every row, every column, and every 3x3 box. Divide the 4 lines in the grid into 2 pairs. The lines in a pair are copycats of each other, i.e. they have the same composition of digits, e.g. if one line has two 3s, 5 4s and a 9, then the other one also has 2 3s, 5 4s and a 9. The order of the digits is not necessarily the same on the 2 lines. Right, so if this line, how should we do this? If this line was paired up with this line, then yeah, okay, so I see you can repeat digits, can't you? So if this line 1 2 3 4 5 6 7 8, it's got 8 cells on it. So say it was 1 1. I'll just try and put as many repeat digits as I can. 2 3 3 4. So say that was the composition of digits on the top line and its pair was this line, then we would have to put 3 1s on the bottom line. This might not be possible to do. 2 2s on the bottom line, 2 3s on the bottom line, and 1 4 on the bottom line. So it would have to have the same digits, but not in the same order. So we wouldn't have to go 1 2 4 3. That would not be necessary, but hopefully that's clear. Now the next rule, the 2 lines in the grid with a circle on one end, so that's these 2 lines, are an average arrow and a thermometer. Now these terms are defined in a moment, so let's just bear that in mind. So these 2 are an average arrow and a thermometer in some order. And the 2 lines without a circle, so the 2 lines on the left-hand side of the grid, this line and this line, are a region sum line and a German whispers line. The solver has to find out which line obeys which rule. Okay, and then it defines what all these things are. So an average arrow line, so that's one of these 2. The digit in the circle is the average, exact, not rounded, of the digits on the line. So let's say that was a 5. If this was a 5 and it was an average arrow line, then the digits along the arrow would have an average value of 5. So if you put a 1 on the line, you'd need to put a high digit to sort of like a 9, and then those two would have an average of 5, wouldn't they? So we would still be maintaining the perfect average of 5. So we'd have to keep doing that such that the average overall was exactly 5. I haven't done many puzzles involving average arrow, and so that already seems weird. And now I think I understand what a thermometer is. Let me just check there's no rinky-dinks here. So let's say this was a thermometer. The digits have to increase along the thermometer starting from its bulb. Right, so if this was a 1, this has to be bigger than 1, because just as mercury would rise as the temperature rises, so our digits must rise along a sudoku thermometer. Now they don't have to rise in units of 1, so we could go 1, 3, 5, 6, 7, 8, 9, and that would break. Actually, that doesn't work because I would have to put a 10 in here, and I can't do that. So we can't skip too many digits along this. But that's the basic principle of how thermometers work. Now, region sum lines, which is either this one or this one, the line is cut into multiple segments by the box borders, each summing to the same number. So what that means, let's say this one was a region sum line. You go along the line until you hit a box border. So these two squares, then you go along the line until you hit the next box border. And then you go along the line again. So you can see this line has 3 segments, and the digits we would put in purple would sum up to, let's say, x. Then the blue digits would sum to x, and the green digits would sum to x. That's how region sum lines work. Absolutely lovely rule. And then German Whisper, 2 neighbouring digits have a difference of 5 or more. So if this was German Whisper and this was a 1, this square would have to be at least equal to 6 in order to be at least 5 different from the digit 1. And those are all the rules. So quite a long rule set actually today, quite a long introduction. Forgive me for that. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Sorry, I was just thinking I did do all my birthdays, didn't I? I think I did. So let's get cracking. So how are we going to start this? I haven't got a clue. Okay. So do we try to understand There are things that I wonder whether it's worth noting generically. For example, whichever one of the left-hand lines is a German Whispers line cannot have a 5 on it. And that's because, say this was a German Whispers line, if it had a 5 on it, the next digit needs to be at least 5 away from 5. And if you go upwards, you get to 10 or higher. And if you go downwards, you get to 0 or lower. So, these lines are all the same length, aren't they? I'm just thinking that would be a very easy way to determine. I think they're all going to be of length 8. Well, okay. Actually, no, that must be because I've already counted 3 lines of length 8. Yeah, okay. So they are all of length 8. So I'm actually going to change tack a bit here. Whichever line is the thermometer, which is one of the right-hand lines, the thermometer doesn't have many degrees of freedom. Because, let's say this was the thermometer. Because it's of length 8, effectively, the options along the thermometer are going to look like that. There's only each cell along the thermometer would only have one of 2 possible digits. You could, for example, if you did try to make this a 4, this would go possibly then 5, 6, 7, 8, 9 broken. So, and if you did pair up then the German Whisper line, which is one of these, with the thermometer on the right, then you would know the exact composition of the thermometer. The thermometer also has another interesting feature compared to the other lines, the thermometer doesn't have a repeated digit on it. All the other lines could in theory have a repeated digit. And how does average arrow work? So average arrow, you put a digit in here. That is the average of all the digits. So mathematically, an 8 cell, yeah, because, right, so there are 8 digits that have an average of exactly 5. So if the average arrow has a mathematical property. The digits on its line, which may include repeats, are a multiple of 8. So if this were, for example, was a 4, then because the average digit has a value of 4, and there are 8 digits, the sum of the line would be 32. 3 would be 24. 5 would be 40. So that's potentially interesting. He's trying to work out why. So all I'm doing at the moment is rereading the rules. So if you... I was wondering whether if I combined the bulb lines together, that feels a very natural thing for me to do, because the thermometer is naturally going to have an averagey type quality, isn't it? In the sense that it's going to have some low digits going up to high digits. So if you no, that's wrong. Hang on. Hang on. Well, I can actually prove weird. Where my brain, I'll tell you where my brain went with that. It said, okay, average arrow feels like a very nice combo with thermometer. And then it thought, yes, because I'd have sort of, the average sudoku digit is obviously a 5. Because it just is. So I was thinking, okay, let's say I put a 5. Let's say this was the average arrow, and I put a 5 in there. And I paired it with this, which would then be a thermometer. Well, that actually doesn't work. But the reason it doesn't work, maybe we have to sort of talk about a secret in order to understand why it doesn't work. And this is a secret I only share with my very favourite people. If you're still with me after 18 minutes, you're definitely one of my favourite people. The secret is that all of the different sudoku digits, the digits 1 to 9, if you sum them, you get 45. So, if this is a thermometer, it's got 8 of the sudoku digits on it, but not 9. So it doesn't sum. The digits on it do not sum to 45. They sum to some number less than 45. But if I'm pairing it with an average arrow that has a 5 in its bulb, the digits on the average arrow sum to 40. Oh, that means this thermometer sums to 40. But it's 8 different digits. So the digit that's missing from the thermometer is 5. Because you've put 5 on the other one, this can't be a copycat of it. Now, what I haven't even begun to think about now is, well, okay, now I can do that. I can extend that thinking. This is weird. So, right, so this line and this line do not pair up together. is what I've now deduced, because let's say this was a 4 instead. Well then, because we know the average arrow, the digits on it have to be a multiple of 8. So we've got, because the average digit is exactly 4, this sums to 32 now. Well, if the thermometer sums to 32, missing one digit, and all the 9 digits sum to 45, what's the missing digit of the thermometer? It's a 13. Well, 13 is not a Sudoku digit. And if I make this a 6, I've gone too high, because 6 times 48, 6 times 8 is 48. And I can't make 8 different Sudoku digits add up to 48, because even 9 different Sudoku digits only sum up to 45. So I've actually already proved then that this one and this one they are not copycats. They are not copycats of each other. So now I'm wondering whether this one and this one can be copycats of each other, because aren't I going to get too many repeated digits or something? This might be nonsense. I'm just going to think about that. If this one had exactly the same composition as this one, what does that mean? Because these digits are all different. So yeah, okay, so I've sort of got my shading a bit incorrect here, but what that's telling us is that so actually this might be quite good, because it might mean this is a thermometer, which would naturally have 8 different digits on it. Because what I'm thinking is, if it's true that the purple line and the blue line are exact copies of each other, then the 8 digits that must occupy purple and blue are all different digits, because these digits in row 3 are all different digits. And these digits would have to appear on the left-hand line. So these digits are the same as those digits. So let's try and do this. And then these digits would be blue digits. And then the 2 lines are the exact same composition, aren't they? Now, and we know this line would be, it's either average arrow or thermometer. So yeah, thermometer's very nice. And this line is either region sum or whispers. So there's a lot of well, there are a lot of similarity, or a lot of options there. I'm just thinking, okay, if we try and make this one whispers, let me just find a way of labeling that. If this one's whispers, the reason that interests me is I know that I can't put 5 on a German whispers line. So where's the 5 in row 3 then? It's there, isn't it? So the only way this is a whispers line is if this is a 5, and therefore that works quite well, because therefore I know the exact composition of the digits on the whispers line, and that it's got to be every digit that is not 5. So it's 1, 2, 3, 4, 6, 7, 8, 9. And that would fit very nicely with a thermo, wouldn't it? Because then this could be 1, 2, 3, 4. Oh, hang on, that doesn't work. Oh, actually, hang on, that definitely doesn't work, in fact. That's weird. Right, so we need to actually think about this a bit harder. If this is whispers, this is not thermometer. and that's because of the order. Because both lines are 1, 2, 3, 4, 6, 7, 8, 9. If this was thermometer, let's just put T in here. What would these 4 digits be? Well, they would be the lowest 4 digits, 1, 2, 3, and 4. But now these digits are 6, 7, 8, and 9, and it doesn't matter what order we put them in. Those digits cannot, these 2 digits, for example, cannot be 5 apart. Even if they were 6 and 9, they're only 3 apart. So that doesn't work. So actually, if this is whispers, this is the other one. What was the other one? Oh, average arrow. So this is average arrow. And if it's average arrow, that doesn't work. It must have a 5 on it. Hang on. Is that wrong or is that right? That feels right. That's beautiful. That is absolutely beautiful. Yes, so what I can see now is that if this is average arrow, because the digits on the average arrow line are 1, 2, 3, 4, 6, 7, 8, 9, I know those digits add up to 40 because it's every digit apart from 5, and I know all the digits add up to 45. So I miss the 5 out, I get 40. But doesn't that mean I have to put a 5 there? And I can't. Because at the moment I put a 5 there, I've got to put a 5 on the whispers line, and I'm in paradox heaven. So that is wrong. So this is not a whispers line. Well, let's be clear. For these two to be copycats of each other, this line has to be, what's the other type of line? Oh, region sum. Region sum line. So this is a region sum, and we don't know what this one is. And we don't know whether this is a 5. But we do know that the digits on this line, are going to be divisible by 3, don't we? The reason we know that is that the way region sum lines work, remember the shading at the beginning? Let's say that these 2 digits, which are the first segment along the line, they would add up to x, say. So these would add up to x as well, and these would add up to x. So the line overall sums to 3x. And obviously then the digits on the line are in total divisible by 3, which means that this line also, its digits are divisible by 3. So, but we don't know now. We do know they are all different as well, because they must be all different. So, so if this, let's try thermometer first. If this, I tried to type in a T for thermometer. So if this is thermometer, the digit missing from the thermometer, because the region sum line has to sum to a number divisible by 3, it's going to sum up to 36, 39 or 42. They are the divisible by 3 numbers, aren't they? It couldn't sum to 33 because that would imply there's a 12 missing off the line, and we know that that's not a sudoku digit. So it's either missing 9, 6 or 3. So this is 3, 6 or 9 in this paradigm. No. Okay. This doesn't work. This doesn't work for a different reason. Yeah, this is really clever. This is really clever. Right. Yeah, I've got it. Okay, so it's not really about this digit. It's about these 2 dominoes and which digits they're selected from. If this is a thermometer, Yet the yellow digits are axiomatically lower than the blue digits by thermometer logic. So how could it ever be possible that these two digits, which are from the yellow set of low digits, sum to the same number as two digits that are definitively higher than both of the yellow digits? It could not be true, could it? So this has to be the other one. Average arrow again. Maverick, what on earth are you flying past my window? It's ridiculous. I'm sorry. Right, so what does... Well, this is going to not work, is it? Hang on, I don't think this is going to work for a totally different reason. Because now I need the line, the left-hand line, which has the same composition as the right-hand line, we know contains digits that sum to a multiple of 3. The right-hand line contains digits that sum to a multiple of 8. So the lines, therefore, the digits on the line sum to a multiple of 24. So that's the lowest common multiple of 3 and 8. But I just don't see how that can be true. Because if the digits sum to 24, we know these lines are only missing. They contain 8 different digits, and they're only missing 1 digit, and there isn't a 21 missing from the line. And if they sum to 48, which is the next multiple of 24, they can't sum to 48 because they couldn't possibly be missing any digits. They'd have to be missing a -3 digit. What's wrong with that logic? If one of them is region sum and one of them is average arrow, the left-hand one's a multiple of 3, the right-hand one's a multiple of 8. The digits, therefore, are a multiple of 24. But the digits on the lines we know are all different because of row 3. Yeah, I don't think there is anything wrong with that logic. I think it's impossible. And so, okay, so now I actually have got to a conclusion. It's only taken me 32 minutes, but the conclusion is that this line is not allowed to partner with the other bulb line. So that line, it doesn't partner with this because we've exhausted every single way that we could make that work. So it's going to partner with this. Those two, the purple lines are copycats, and by a process of elimination, therefore, these yellow lines are copycats. Right. And that is going to put an immense fly in the ointment, isn't it? Because now what I can see is that I learn very little about the nature of the lines now. What do I mean by that? Well, it was really quite pretty when these two lines were copycatted, because I could immediately then tell there were 8 different digits on the line. But now I have no such luxury. The yellow shapes, if you like, have almost no interaction. They interact very slightly in column 5, and in row 5 there's a tiny interaction between the purples. So it's absolutely fine now for the yellow, for there to be repeated digits. I suppose not on the thermometer line, which is one of the right-hand lines, isn't it? So one of these lines definitely is a thermometer. And the thermometer is pairing up either with the whisper or with the region sum. I mean, how do you actually even... Oh, I don't know. That's actually, I almost feel like I've been reset back into the Stone Age here, because I actually don't know anything now, do I? I still know that if the thermometer pairs up with the whisper, although I don't know which way round it would go, at least I would know the composition of both of those lines. But if the whisper paired up with the average arrow, I wouldn't, except I would know that the average arrow, the digit in the circle of the average arrow, couldn't be a 5, because then they couldn't be copycatted. And then the thermometer would pair up with the region sum line, but that's surely fairly easy for it to do. It would be missing a 3, 6 or a 9 off the line. Oh no, is that even true? No, because it could have repeated digits on it. So although the digits on it... Oh, hang on, now I'm confusing myself, sorry. No, I'm going to go back. What I'm going to think about is... Actually, I don't know. I'm not sure how to do this. I want to... See, how am I ever going to know which way round the lines go? So even if I came to a conclusion... Let's say I came to the conclusion that average arrow paired up with region sum. Why would I know which way round? Why would it be that way round rather than this way round? No. I thought maybe I could... that's so annoying. Right, that line has the same number of segments as this line. It's got 3 segments. So I don't think it's going to be that. So average arrow. I don't understand. Something weird going on. I haven't understood something about the puzzle, I think. There's no other rule, is there? No, I don't think there's a rule. I don't know. All right, I'm going to go back to a different thought I had, which isn't really about the geometry and the grid so much. It's about the mathematics of the grid. If the German whisper, we know if the German whisper line partners up with the thermometer, at least we would understand the composition of both of those lines instantly, because we couldn't put 5 on the whisper, therefore the thermometer would be 1, 2, 3, 4, 6, 7, 8, 9. What if that's not the case? If the whisper partnered up with the average arrow, then what we can't do is put 5 in the bulb. Let's say this was the average arrow and we put 5 here, and we're claiming it partners up with a whisper, so let's put W in here. Let's put W in there. Now, so that can't be true because we can't put 5 on a whisper line. So the average number here is going to be some number that's not 5. And that's interesting a little bit, I think, because I feel like a whispers line wants to try and average around 5, and the reason I think that is because of the property of polarity along a whispers line. So if this was a whispers line, let's think about the nature of this digit. It would have to be either lower than 5 or higher than 5. Let's just imagine it's lower than 5 for a moment. The point then is that this is not also lower than 5, because these two digits cannot naturally be 5 apart. So this would have to slip the other side of the 5. And similarly, this would then slip the other side of the 5, so that you get this oscillation of polarity. So when I say that I want the average of the whispers line, if it's paired with an average arrow, to be 5, it's because I know that each pair of digits along the line is going to contain one digit that's higher than 5 and one digit that's lower than 5. Now, of course, it's more complicated than that, because in theory, this could be 6 and 1. Averaging 3.5, or it could be 9 and 4, averaging 6. Sorry, averaging, what's that average? 6.75 or something? No, 13. 6. What am I talking about? 6.5. For some reason in my brain, I went to 13.5. Then I don't know why. So you're going to have 4 pairs of digits. So if you had 4 6s, so I'm just wondering if, right, okay, so here's one thing we can say. If we tried whichever of these lines is whispers and one of them is whispers, it has 4 pairs of digits on it from a whispers perspective. And even if all of the high digits on that line were all 6s, which is the lowest they could be, and all of the low digits on the line were all 1s, which is the lowest they could be, and that we could never do that because, for example, this pair of digits couldn't be a 6-1 pair if that pair of digits was a 6-1 pair. But just for the sake of exposition, the reason this is interesting a little bit is that the line, the minimum you could in theory make the whispers line total would be 28. 4 times 6 plus 4 times 1. Now 28 in the context of an average arrow line is more than putting a 3 in the bulb, isn't it? So if you put a 3 in the bulb, the line should add up to 24, and it can't. There is no way you compare a whispers line with an average arrow and have a 3 in the bulb of the average arrow. Now let's try that the other way round. If you put 9 and 4 into every domino, you'd get 4 lots of 9, 36, and 4 lots of 4 is 16, 52. So 52 is, yeah. So what you could do is have a 6, but you couldn't have a 7. Because 7 8s are 56, and 56 is more than 52. So actually, it's quite interesting. This digit has to be a 4 or a 6. If you pair the whispers line and the average arrow, you have to do it with a 4 or a 6 in the bulb of the average arrow. Can't use 5 because you can't copy the 5 onto the whisper, and anything lower than 4 is impossible because of the nature of the polarity of the oscillation along the whisper. That feels interesting a little bit. But if you do put 4, you'd have to put 9. 4, 32, 13, 19. No. Okay, this is getting very interesting now. Now, hang on, let me just think this through for 6. If you do 6, 6 and 1 is 7. Minus 48 is 41. 20, no, it's nowhere near. Yeah, is this right? Got it. Okay, so I am now going to claim I can't pair the whisper with the average arrow at all. This is beautiful. Good grief. I could have got this right at the start, couldn't I? Let me just think about that. Yeah, I could. I mean, this is right. This is just true. What I'm about to say, well, no, it's just true. It is just true. You cannot ever pair an average arrow in a sudoku, in this sort of sudoku, with a whisper. They can't be copies of each other, because the moment I put 4 in the bulb of the average arrow, what do the digits on the average arrow sum to? Well, 4 8s, 32. That means this has to sum to 32. But one of the low digits on it is a 4 now, and 4 is monogamous. So let's say it was that one. What do I mean by monogamous? I mean it only has the partner of 9 along the whisper. So the moment we put 1 4 in purple, we must put at least 1 9. I mean, if you made that a 4, you'd have to put 2 9s in. But the absolute minimum you have to put in is 1 9 if you put the 4 at the end of the line. Now that means that by putting a 4 here, one of the 4 pairs on the whispers line sums to 13. But the overall line we know sums to 32. That means the other 6 digits on this whisper have to sum up to 19. And that's impossible, because 3 of the digits are high. 3 of the digits are at least 6. So once I've even put 6 in, I'm already up to 18. I've still got 3 low digits to come. It doesn't work. And what happens if I make this a 6? Well, now there's going to be a 6 somewhere on this line. Let's change the polarity. Let's make that the 6 in order that I only have to have 1 1 on the line, because 6 is also monogamous. It only partners with 1 on German whispers lines. So by putting a 6 on, I have to put a 1 on. So this line, now we know sums to 48. 6 and 1 is 7, which means the other 6 digits on the whisper have to sum up to 41. And even if each pair contains a high 9, so we can't do it here, but if we imagine we did that, which is such nonsense, it's not true, but just for the sake of exposition it's helpful, that only gets us to 27. And even if we pack 4s into the other positions, that only gets us to 12 more than 27, which is 39, which is not 41. So you can't do it. You just can't do it. And that's obviously something that Phistomefel understood, but I have only just understood. And that means, well, okay, so what that means something very profound, doesn't it? Because that means that somehow we are pairing the whisper with the thermometer. And that means that one of these, whichever one of these is the thermometer, is made up of 1 2 3 4 6 7 8 9, because it cannot have a 5 on it, but it has to have different digits on it because it's a thermometer. So that means that whichever one of these is the whispers line, how exactly is this going to... See, we're back to the problem that I thought about before, but I couldn't understand how I was going to resolve it. And the problem I thought about before is, what is it that's going to determine... You know, I now know that I have to partner up one of the left-hand lines as a whisper with one of the right-hand lines, which is a thermo. I even, you know, if I knew where either one of those things was, I would be away. But we're either putting 1 2 3 4 6 7 8 9 here, and then this would be a whisper with that property, or we're putting 1 2 3 4 6 7 8 9 here. This would be the whisper. So maybe I've got to alternate the digits. Maybe there's some sort of polarity thing going on. Oh, that's horrific there. Let's have a look at it on this line. That looks more interesting. That does look more interesting. This one, if it was a whisper, what I'm noticing there is that these 3 digits are all of the same polarity. So is that putting some pressure on this domino, maybe? And so what's the other pairing that we've got going on now? We've got a region sum line on the left. Okay. So we've got a region sum line on the left partnering an average arrow on the right. So we are in a mathematical world, aren't we? Because we know that the region sum line, whether it's this one or this one, it's got 3 segments. And we know the average arrow is a multiple of 8. So we know that we're either looking for 24 as the sum of the digits on this combination, or 48. We can't go higher than that, can we? If we go to 72, so if we go to 72, because we can have repeat digits, so if one of these was 72, we'd have a 9 in its bulb. 9876, 987. What's that? 30, 54. No, it's nowhere near. No, that one can't do it. That one can't get to 72. Now this one looks like a no, that one can't either. It's got the same sort of property in the sense that those 4 digits have to be different and those 3 digits have to be different, just as those 4 have to be different and those 3 digits have to be different. So they actually have the same property. Sorry, my phone is buzzing. What's that about? Nothing important. So yeah, so there's no way we get to 72. So that's right. So the bulb of the average arrow then is a 3 to give a sum of 24, or a 6 to give a sum of 48. So the bulb, so the region sum line on the left-hand side, which we know has 3 segments then, summing to either 24. So if it was 3 segments summing to 24, I might see a way we can do this now. Right, because if no, it's okay still. Well, okay, what I was thinking is, if it was 3 segments summing to 24, then each segment on the region sum line sums to 8, because there are 3 segments summing to 24. Now, you can't make that. You can't make this segment sum up to 8, because there are 4 different digits in that segment, and they would sum up to at least 10 if they were 1, 2, 3, and 4. So this couldn't be a 24 region sum line. This one, though, maybe it could be. Well, it could be, but not with 1, 2, 5 there summing to 8. Because if these were 1, 2, 5 summing to 8, how do you make that domino sum to 8? It couldn't be 1, 7, 2, 6 or 3, 5. That would have to be nothing. It wouldn't work. So this would only work if that's 1, 3, 4. And then this would be not 1, 7 and not 3, 5. That would be 2, 6. And this would, again, it would have a 1 on it, wouldn't it? Well, let's just think about it the other way round. Maybe we can eliminate it more quickly the other way round. So if we put a 6 in a bulb, 48, then the 3 segments on the left-hand side are summing to 48. So each of those is 16. Right, that can't be there, because 16 is a single. There's only one way of making the total. You'd have to do it with 7 and 9. And you'd have to put a 7 and 9 there as well. That would be the only way you could do it. So if it's... So hang on. So this is never then. This is it. We've done it. That's beautiful. Right. So whether the total on the average arrow is 24 or 48, this top line cannot accommodate a segment size of 8 or 16 for different reasons. It can't do 8 because it has a 4-cell segment, and it can't do 16 because it has 2 2-cell segments. That is so clear. This is ridiculous as usual from the great man. Right, but now we're there, because now I know that it's this one, purple. This is an average arrow, because yellow can't be the average arrow region sumline combination. This is region sumline, this is thermometer, and this is whisper. And now I know the composition of this line, so I'm going to get digits. I'm going to get plenty of digits now. Now this line, right, so this is a whisper, so it's alternating polarity. So it's those digits have one polarity, and this is not going to be as good, is it? Although the two ends, yes, okay, yeah, got it. So, right, this is interesting. This is interesting. Let's think about the monogamous digits and how they're going to fit in to this top whisper line. So I'm thinking about the digits 4 and 6, which can only partner up with the digits 1 and 9 on a whisper. Is it now possible to put those digits in any of the central positions along this? And you may say, yes, you could put 4 there. No, you can't, because that was going to cause 2 9s to appear on the top line. And there are, remember now, we're dealing with all different digits. So the only place you can put the 4, and the same is going to be true for the 6, which would cause 2 1s. The only place you could do it, you've got to put them here. These are a 4-6 pair, and they are next to a 1-9 pair. And we've got to keep that going. What do I mean? Well, let's think about 7 on this line now. Wherever I put 7, it must be surrounded by 1 and 2, which are the only digits that are 5 away from 7. So the 1 on the line, which I know is in one of those positions, must be next to a 7 on the line. And the same is going to be true with the 3. The 3 can only be next to 8 and 9, and therefore must be next to the 9, which is in one of these. And these digits are 2 and 8. And this digit, which is the average arrow digit, we know is a 3 or a 6, don't we? Because we know that this line has to add up to something that gives a multiple of 24. Because this is a multiple of 3, and this is a multiple of 8. Yeah, and you can see whatever this is, it's going to crystallize everything on this left-hand line. So that digit determines everything here. So if this is 3... No, right. So when we looked at this being a 3, we know that the region sum line divided into segments of size 8, didn't we? So if this is 3, the way that worked was that these squares were 1, 3 and 4, because they couldn't be 1, 2, 5. And these squares were 2 and 6. And now I've got too many 2s in column 2, because I know there's a 2. That's so clever. So because you can resolve the approximate shape of the whisper, and you know there's a 2 in column 2, it rules out one of the options. It's just, how do you set this nonsense? So this is a 6. This is a 6. This is a 4. So this is a 9. This is a 1. This is a 2. This is a 3. This is an 8. This is a 7. All of that is just absolutely forced now. But now we've still got, so we've got 48, so 16. Oh, yeah, this is fine. Well, it's not broken at least. Right, this is the domino I was suddenly worried about, because that has to add up to 16. And there's only one way. We looked it up here. So this has got to be a 7-9 pair, so it's got to be that. So these 3 add up to 16, and those 3 add up to 16. And I've got to put, ooh, Oh no. Okay, I thought I was going to get good. I've got to put 9 and 7 on this one, because I've got 9 and 7 on the left-hand line. I've got to put 9 and 7 on the right-hand line. And 9, look, is in one of those squares. I mean, it's a dreadful way to do the pencil mark, but forgive me. 7 is less clear. Oh, well, although, okay, no, it is less clear. So 7 in row 3, because it can't go there, is on the line. In fact, it's in one of those two cells. I'm also going to pencil mark that. So that 7 is married up with the 7 here. The 9 is married up with a 9 in one of those three. Now, what can we do with that? We could... does there need to be an 8 there? Yes, doesn't there? If there was no 8 in that 3-cell segment, then the maximum digits we could include there would be 4, 5, and 6, which add up to 15. And we need the segment to add up to 16, so there is an 8 exactly here. These two squares add up to 8, and they're not 1, 7. So they're either 2, 6, which would be that way round, or 3, 5, which would be that way round. They're either 2, 6 or 3, 5, and that's going to put digits over here as well, isn't it? Now there is an 8 now on the purple line. Yeah, nearly. Well, no, it's not brilliant. There's an 8 in one of those because there can't be an 8 here. There's a 2 on the purple line in row 3 because of that 2 not being able to be there. So there is a 2 in one of those places. So there is a 2 in... Ah, that's beautiful. Good grief. Right. Where is 2 on the purple line? Because in row 3 I know there's a 2 in purple. I've got to put a 2 in the left-hand purple now. Where does it go? It doesn't go there by sudoku, and it doesn't go there by sudoku. So it must be on the purple line in box 7, and there's only one place it can go. So that's 2, that's 6. So there's now a 6, which is that one. Right, so we've got a 6, a 2, a 7, a 9, and an 8. So, okay, so we've sort of approximately mapped everything we know already to the purple line. Now, what do we do with this knowledge? I hear you ask. 9, I'm going to do sudoku. It's against my better judgment, but there we go. Can I do more sudoku? 2, 4, 5 in row 7. No, nearly. Those squares is what I was looking at. That can't be 2. And that can't be 4. No, that didn't do anything, did it? Let's try. Is there any more sudoku? 1, 5, 7, 8. That digit's a little restricted. 5 or 8. In column 5. 1, 3, 4, 5. That digit has to go on this line, doesn't it? And it obviously can't go in those 3 squares, so whatever that digit is, I'm actually going to label that 1, 3, 4 or 5 by sudoku. Well, that is useful. That's not a 4, because if that's a 4, where do I put the 4 on the purple line? The answer is nowhere, because it rules itself out of all those squares by sudoku, so that's not 4. So, If it's 1, it gets interesting as well, actually. If that's a 1, where do I put the 1 on the purple line? It can't go there or there, so it'd be in one of these two squares. I will put a 1 in the corner, or 1 here. It's almost ruled out. If it's a 3... Yeah, it's interesting if it's a 3 as well, because if it's a 3 it can't go here and it can't go here, so it has to go there. So if that's a 3, that's a 3, and if it's a 5, no, then it's not as good. It's got lots of options. So what's this digit then? Because this is the digit in row 3. This is the only digit that we don't know about that's not on the purple line. So that digit is 1 or 5 by Sudoku. So there is a 1 or a 5 in those cells. That's interesting. And that digit, oh no, it's, hang on. So if that's a 1, there's a 5 on the line. If that's a 1, that's a 1 by Sudoku. One of these cells would be a 1. I don't think you could then put a 1 on this line, because this would be too small, given that there must be a 5 on the line. Yeah, so whatever this is, it's that feels like quite a pivotal square. Sorry, I can't speak. That's a 1. 5 moves over here. 5 can't go in the pentomino at the bottom here, so 5 would be on one of these. With 2 digits that added to 11. But if that's a 5, then there's a 1 over here. There's a 1 in one of these, which is going to be with 2 digits that add up to 15. Well, that I can nearly rule that out, actually. Okay, so what I'm noticing is if this is a 5, because I have to put 1 on the line here, where do I put the 1 in this box? Given that the other 2 squares have to add up to 15, I can't put the 1 here or here, because this can't be big enough to get me to 15 with just one other digit. I mean, we could go 1, 5, but then this digit would have to be a 10. So if this is 5, this is 1. And these two squares would be a 6, 9 pair, actually. That feels difficult. There would be 2 6s and 2 9s. I'm just going to think about that. So what I'm saying is, if this is a 5, this is a 1, and this is a 6, 9 pair, so I'd have 2 9s and 2 6s to put on this line. So the 2 9s would have to go into those 2 positions, wouldn't they? Because they're the only places that 9s can go by Sudoku on this line. I'd have to put 2 9s into these positions. I've got to put another 6, which would go in one of those, along with 8, I suppose. See, that looks like it's going to work, doesn't it? What doesn't work about that? The answer is I can't see. I cannot see why that doesn't work. No, not sure. So, no, that's no good. Okay, I can't see why that doesn't work. But I did notice, as I was thinking about that I can just write 6 into the grid there, look, by Sudoku. So I will do that, and I will take a small crumb of comfort from that. In fact, I'm going to write 6 there as well. That's getting very constrained now. That has seriously constrained what's going on this line. Because now I'm noticing if this is 1, then this is 6, this is 9, that's 9. There might be some reason here that I haven't quite figured out that stops all this working. I've got a 135 triple in row 8. That digit, which is a 1 or a 5, definitely goes in that square, doesn't it, by sudoku. So that digit is the grey digit. So it's got to find a home in box thingy. Right, so the grey digit, which is not in these squares, is either there or there as well. So it's in one of those 2 squares, and therefore it's in one of these 2 squares. I think this is going to run. This is going to run dry, isn't it? It would be lovely if we could limit this square somehow. Or there's a 1 here. Ah! Oh, that's beautiful. Oh my goodness me. Right, I've got a different way of ruling out this cell. I don't need to use the 9 and the 6 and trying to map them to this line. All I need is that 1. It can't be a 1. It can't be a 1. Because if that's a 1, remember that what causes this to be a 1 is this being a 5. Because that puts 1 on the line over here. And therefore I have to put 1 on the line down here. And we worked out that 1 would have to go in this position, because if it's in either of these positions, this isn't big enough to make the other 2 digits add up to 15. And now I've noticed, look, 1 can't go anywhere in box 1. It doesn't work. So this is a 1, is what that's saying. So that's a 1. Oh, bobbins. That's probably not the way round we wanted it, but okay. This is definitely not a 1. Well, actually, is that still true? I think it is true. Yeah, that can't be a 1 now because I couldn't put a 1 on here. That's what that causes. So this is only 3 or 5. So probably what we've got to do is to think that through. So if this is 3, these add up to 13. Right. In fact, let's label these digits up now. What are they? They're 2, 5 and 7. That's not 7. So one of these digits is a 5. So if this was 3, it would have to go with 5 and 8, and that would be in a specific order, because I must have a 5 on the bottom line. So if this is 3, that can't be 8. So this is 8 and this is 5. So if this is 3, it goes 8, 5. If this is 5, these 2 digits add up to 11 without using 2, 9 or 5, 6 or 3, 8. That square could be neither 3 nor 8. So if this is 5, this is 4, 7. And that's in a specific order. 7 there, 4 here. This is never 5, we've just discovered. So 5 is in one of those 2 squares. This is never 1. These squares are 3, 4, 5 by sudoku. Oh, we're getting close now, aren't we? So, whatever this digit is, there are 2 of it on this line. Because 7 and 8 both appear already on the line. So whatever this is, it has to appear twice. Oh dear. has to appear twice. So if it was, yeah, if it's 8, that's quite challenging. Oh no, that's right. That doesn't work. That's it. There you go. It's as simple as that. That can't be 8. And that's because 8 now has to appear. So if this is 8, remember these two digits have to add up to 8 to give us our 16 segment. So this is 3 and this is 5. Now, how are we going to make this work? Because we've not put 3 on this line, but we can. It would have to go here. But I've got 2 8s to put on this line now, and they have to both go in that little segment of 3 digits, and that will not work. That Sudoku will break that. So I think that has to be a 7. These two have to add up now to 9, which means they have to be 5 and 4. That's a 4 by Sudoku under that logic. What are these squares? 1 and 3. Now we know the exact composition of the right-hand line at last, because we've put 2, 5, 6, 7 on it. 2, 5, 6, 7 on it. So 4, 7, 8, 9 is what we put into these squares. These are all different digits. So that is not 9 or 7. These are not 4. Well, you can't put 7 in this domino, because if you put 7 in this domino, I can't put 7 at all in box 2 because of that 7. So this is an 8-9 pair we've just discovered, and that means this is a 4 and this is a 7, because we know all these digits are different. This is so clever, Phistomefel. This is so clever. Right, that's become a 7 by Sudoku now. That's a 7. There are 4 7s looking at box 3. I've got a horrible feeling. You know, that this is Sudoku from now on out. I might be wrong about that, but no, that's a 5 by Sudoku. That's a 9. We need to put 8 into one of those. It's a 2-8 pair. Oh, we don't know the order. But now there's an 8 in one of those, so there's an 8 in one of these, because we need to put an 8 in row 6 is the way to think about that. Now these squares are 6 and 9. Okay. Now I need to put 9 in this row. That's got one of 2 places to go into. What? Oh, how should we do this then? No. What I was about to say is nonsense. Try not to talk nonsense. It doesn't help to solve Sudoku puzzles, as a rule. Okay, now I'm stuck. Oh dear. Is it really just Sudoku at this point? I think it feels like it ought to be. But why can't I see what on earth to do then? There is a 6 in one of those. Oh, there is a 6 here. So that's a 6. That's a 6 and that's a 9. That's a 9 and that's an 8. Okay. That's an 8 and that's a 2. That's a 2 by Sudoku. So this is 4 or 5. So this is a 2 by Sudoku. That's a 2 by Sudoku. 3, 5. Well, this column should be done. 3 and 5. Yeah. 3 there. 5 there. 7, 8 pair here. These have got to be a 5, 8 pair. So these digits are 1, 3 and 9. And that's not 9. Chance of a 3 in the corner. These squares are 4 and 8, which I can actually resolve. That's not 8 now. So this is 8, this is 9. Very good chance for 3 in the corner. Getting closer all the time to a 3 in the corner. I need 1, 3 and 5 into these squares. Let's pencil mark that and see if we can figure that out. No. Bobbins, I don't know. Okay, let's try. This is a 1, 3 pair, isn't it? So I've got to put a 1 there and a 3 there. It doesn't resolve this 1-3 pair. I still need to put 4, 5, and 7 into... Oh, this must be resolved somehow. I just can't see immediately how. 4, 5, and 7 into box 5. How does this happen? So there's a 4 looking at that one. Right, that's 5, that's 7, that's 4. So that's 5 and that's 8. That's 8 and that's 7. Yeah, I've got a worrying looking amount of 1-3 pairs going on. I've got a 1-3 pair in column 8. So that becomes 5 then. So that's 2 and that's 5. That's 4 by Sudoku. That's 5. That unwinds some chocolate tea pottage down there, look. This is a 1. This is a 3. Ah, that's good. That is good. Here we go. Oh, maybe not. That. Oh, hang on. What's going on now? 2 and 3. Ah, I do get a 3 in the corner, but it's there. That's a 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, losing its religion. There we go. What a puzzle that is. How long has that taken? 1 hour and 20 minutes. Yay! That is magnificent. Absolutely magnificent. Ridiculous puzzle. Absolutely ridiculous puzzle. Copycat Confusion. It is totally correct as a title. It is confusing. It's very difficult, or at least I found it difficult to think clearly about how to do it. And it... You see, I wonder if I'd just not done anything at the start and just thought more carefully and for longer about which pairs of lines could marry up. Because it was the critical point was realising, well, no, it's not easy. It's not that easy. Firstly, you've got to prove that average arrow doesn't marry up with thermo. Then you have to have the thought that average arrow can never pair up with whisper, which is a weird thing. That was very difficult for me to see. And then you can realise that you can disambiguate the ordering of the lines. And it's still not that easy to finish from there. It's brilliant. It's classic Phistomefel. A longer video. I know some of you like the long videos. Well, I hope you enjoyed it. I hope you had a go at the puzzle and witnessed the baffling brain of Phistomefel again. We should call him the Phistomefel. It sounds more sinister. Anyway, let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.